and welcome to 18-4, where we're going to be dealing with enthalpy, entropy, and free energy. This whole section deals with why reactions happen spontaneously. And so this whole topic deals with an area of chemistry called thermodynamics. It's a large branch of chemistry that we're only going to scratch the surface on in this section. But it's for those who are going to be engineers in the future, this is a topic that you're going to spend a lot of time discussing at the next level. So first of all, what do we mean by a spontaneous reaction? I'm sure that conjures up lots of different images in your mind. Spontaneity simply deals with if or reaction will occur. So let's define this as spontaneous reactions occur without outside influence. That is, they happen on their own. Alright? As opposed to non-spontaneous reactions that do not occur on their own. Now, what do we mean by the fact that they occur, they don't occur? Well, first of all, the spontaneity has nothing to do with speed. Some spontaneous reactions take literally millions of years to occur. For example, you can have a diamond spontaneously turn back into charcoal. But that's not going to happen in our lifetimes, nor our kids' lifetimes, nor generations after generations. That is going to take so long that nobody's going to be around when that happens. All right? So the fact that that is a spontaneous process does not mean that it's going to be a fast process. On the other hand, a non-spontaneous reaction does not mean that it's impossible to happen. It simply means that it doesn't happen on its own. Most reactions are spontaneous in one direction, which means they're non-spontaneous in the other. Charcoal does not spontaneously turn into a diamond on its own. You have to have outside influences such as high pressure and temperatures and those types of things, and that happens inside of the Earth where diamonds are formed. So we know that coal or carbon does turn into diamonds, except it has to have certain types of conditions. So you can have non-spontaneous reactions occur, it's just you have to make them happen by adding some type of energy to them or put them into the right under the right conditions. Now, why do spontaneous reactions happen? Well, it boils down to the three topics that are the titles, or is the title of this chapter. We need to learn about enthalpy first. Then we're going to talk about entropy, which at the end of the day is really what's governing the universe physically speaking. And together they will form a concept called free energy. And so let's go ahead and define what those things are and then talk about how they determine the spontaneity of a reaction. So let's go ahead and lead off with enthalpy. Enthalpy is given the symbol delta H, or just H. We typically use delta H, measuring a change in enthalpy. And what it is, basically, is the heat of reaction. And so heat can enter the reaction or it can leave the reaction. And so if you have a delta H that is less than 0, meaning delta H is negative. Well, if delta H is negative, that means that you're losing something, and you're actually losing heat or releasing heat. Well, any process that releases heat is going to be termed exothermic. And if you put your hand up to it, you would actually feel the warmth coming off from it, depending on how much heat is actually being released. This is actually favorable in terms of spontaneity. Nature tends to lose energy. And so if a reaction will lose energy or release heat, for that reaction that would be a favorable condition. It doesn't mean that it absolutely has to happen, but that would be more favorable than not. As opposed to the other side, if delta H was greater than 0, meaning that it had a positive value, if it's a positive value, it's gaining heat, or we just say absorbing heat. And if it absorbs heat, it's going to be called endothermic, and that is not favorable. Doesn't mean that it can't happen. In fact, there are lots of endothermic reactions. It's just that it is not as favorable as releasing heat. So if you have heat in terms of one being favorable and one being not, there obviously are other factors that are playing a role in whether or not this thing is going to be spontaneous or not. And that other factor is what's called entropy. Entropy, which we give a symbol S, or we'll talk about a change in enthalpy, delta S. Entropy is simply the randomness of the molecules. That's randomness of the molecules or particles. And what do we mean by that? Well, let's take a look at it as you go from, say, a solid to a liquid to a gas. What happens to these particles? In a solid, you have all the particles lined up in a regular fashion most of the time. And so this would have a high degree of order and very low randomness. When you get to a liquid, though the particles are packed tightly together, they are allowed to move around one another. Okay? So since they are allowed to move around one another, there's a little more randomness involved with the liquid. And then when you get to the gaseous phase, the particles are far apart, and they're moving in all sorts of different directions. This could be going in that direction, this could be going in that direction, this could be going in that direction, that could be going in that direction, and the particles move in a random fashion. So as you go from a solid to a liquid to a gas, you have an increase in randomness, or you have more entropy. All right, so that's basically what we're talking about there. So let's talk about it in terms of favorability. If you have a delta S that is less than 0, meaning that it has a negative sign, what does that mean? It means that it's becoming less random. Well, if something is less random, that means that it's going to be more ordered. And that is not favorable. The universe tends not to order itself, although that's not the only factor. In fact, there are instances where things do become more ordered, but it is not a favorable situation and tends not to happen that way. Now, what if you had the opposite? What if you had delta S that was greater than 0, meaning that it had a positive value? All right. If it has a positive value, it's going to be more random or less ordered. That is favorable. And it tends to be more favorable simply due to probability, as it turns out. So, you have enthalpy and entropy both having a hand in whether or not something is spontaneous or not. In the next podcast, we're going to combine those two in a term called free energy and explain how you can predict the spontaneity of your reaction. We'll see you next time.